The objective today is to choose a binary encoding for specific pieces of information and justify those choices. So you'll create a diagram, see the example on the next page, that shows how you broke down your experience into pieces you could represent with ASCII or numbers, that is binary. So this is a lesson that I'm tagging on the end of a lesson previously done called Encoding an Experience, where you get to think about an experience you've had in life and then encode that into a digital experience. What we're doing when we break down this experience is something called top-down design, a design process that begins by specifying complex pieces and then dividing them into successively smaller, less complex pieces. So pick one aspect of your experience to show with detail how you would encode it in binary. You will develop a detailed encoding protocol explaining precisely how that portion of your diagram would be encoded. You will make a table that has a row for each component that lists the following information. So for example, it says component, name the component, type, ASCII or just a number, the number of bits / range, so how many bits do you need, for text, how many characters, and then a description / comment. So explain how or why you encoded it the way you did. So do not go any further if you want to embrace your own creativity here. So I'm going to give more details as to those last 2 slides. Go ahead and pause the video and just start going for it. But if you need more direction here, I will go ahead and provide that. So here's a diagram of a birthday party. The first dot says, think about the major categories that make up that experience. So with the birthday party, we have the start time, food, conversations, and music. Then consider whether any of those components can be immediately encoded into ASCII text or numbers. Then for the rest of your components, keep breaking them down into subparts until a path in your design tree ends in ASCII or a number. So if we follow this path here, conversations can be broken down into participants, the topic, things that people said, and the location that these conversations are occurring in. The person creating this diagram chose to go further into the things said with the time, which is a number, a tone, which is something we can assign a number to, the volume, which can be assigned a number, what they're saying. Going back to ASCII, we can take what they're saying and break it down into ASCII, and then the name of the speaker, thus another ASCII number. So the example shows how we chose to break down attending a birthday party. We chose to include the start time, food, music, and conversations as the major categories, but there are certainly many others we could have added. And I just want to add to this paragraph that I made a typo here. This period is outside of the quotation marks. Now, encoding, depending on the computer language, like that might be something that happens. But in English, in the papers that you write, in the responses that you give me, I've noticed a lot of you are making the mistake of putting the period or the comma outside of the quote. That's just not how English works. You need to put it inside. So don't forget to do that. I considered remaking this part of the video, but seeing how often I see this mistake, I just want to point it out. I know it's not English class. I know we don't do a lot of writing, professional papers in here, but geez, it's definitely something you should learn at the high school level. And that's it. Okay, so let's get back on track here. It says at the top level, start time could be encoded as a number, but we couldn't figure out a way to directly encode conversations. So we kept breaking it down, dividing it into participants, a conversation topic, the thing said, and a location. We even decided that the thing said would need to be further divided to truly capture the experience. Each thing said at the party was broken down into pieces that could be encoded as ASCII or a number. So everything in this diagram represents choices we made. A correct way to encode something depends on how you justify the choices you made. Here is a detailed version. Thing said. Every time a person says something in a conversation, their comment, question, etc. is encoded. By combining all of the things said, it is possible to recreate the conversation. And just think about devices out there such as Siri on your phone or Alexa from Amazon. This is essentially what that software is doing. So the first component, speaker, type ASCII, number, 256 bits, so that's not surprising. And then the description here. It's the name of the person speaking. 32 characters should be enough for most names. It is important to know who said what. The second one, what they said, another ASCII data type, and we're going to go with 8,000 bits there. We got to cap it off. That's a very important concept in computing. You definitely want to put limits onto things, or else you can have some major problems. The text of what the speaker said contains the actual contents of the conversation. I figured that a person wouldn't speak for more than 1 minute at a time. I found that a typical American speaks at most 150 words per minute. What does that number look like to you? 150 words per minute, 150 characters? In Twitter, I forgot how much Twitter limits you in terms of characters or words, but I think it's around the same. Moving on, the average words have 5 characters with spaces. That is 900 characters, so 1,000 is sufficient. So this creator here obviously did some rapid research to find support for their decision here with their encoding protocol. So if you need to do that for the example you come up with, do the rapid research. And the last one here, volume, which is just going to be a number. We will go ahead and give it 7 bits and measure it in decibels. A rock concert is about 125 decibels. So the range of a 7-bit, 0 to 127 is enough. Okay, that's plenty. It will help us gauge how loud the party is. I think typically conversations in a party will not ever get as close to the sound that a rock concert is making. And when you're encoding things, programming things, you always want to give yourself some wiggle room there. So that's what this person did, and that was a good idea. So here's an optional think, write, share. Anything you can think of that would be missing from this conversation encoding, because these next two are the last 2 pieces I have for you. Tone is another ASCII data type. You have 128 bits for this. How the person said something, for example, laughing or serious. This will only be a short 1 or 2 word description to help reconstruct the tone of the conversation. And our last one, time. This is just a number data type. We're going to go with 16 bits. When the thing was said, we will measure in seconds since the beginning of the party. So 16 bits provides 0 to 65, 535 seconds, or a little more than 18 hours. If it's a long party, that is a very long party, 18 hours. This is important for knowing the order of comments. Yeah, this is a data type that you just could not leave out if we're going to reconstruct a conversation. For this project, you'll submit to your teacher diagram showing the breakdown of your experience, your detailed encoding table showing the binary components of a bottom level of your diagram tree, and your written responses about trade-offs in representing information as digital data. So try to balance your creativity, technical details, and time. I just want to get this done in 1 class period, so I'm going to wrap up this video quickly here. Look at the clock, see how much time you have left in class, and we'll go from there. So this is the DOL, okay? Topic. I want you to assign an RFC number to this. I think that'd be really cool. So if you remember, RFCs are just technical documents. RFC stands for Request for Comments. So choose your favorite number. Mine's 23 for Michael Jordan. So I would call mine RFC number 23. And then you just fill out the table. DOL for you rubric lovers. You could check out the next slide. That is how I will grade your work today. So here's the rubric. For everyone who likes them, you can pause here if you want to read it. I'd shoot for the highest score possible, please. And then don't forget to just come back here. This is the example that I want you to model your DOL off of. So this is what you're going to turn into me. You can easily create a table on Canvas. So this should go through Canvas. But this one right here, the actual diagram, if you just want a piece of printer paper, I'll throw one your way, and you can sketch it out and hand it in for additional points.